derivatives. Right? I always think about this course as two courses in one, right? You got a section on derivatives, you got a section on integrals, right? So if I go back to derivatives for a minute, and I said, guys, here's a function, and here is a point A, and here is a point B. Can you give me a slope between A and B? Could you give me a slope between A and B? We'll call this function f of x. Well, boom. Would there be a slope? Yeah, so if I asked you for a slope, you could say it's f of b minus f of a over b minus a, right? What am I doing here? Change in y over change in x, correct? All right. And let's suppose that we did that for this problem, and let's just pretend. Let's just pretend that we got 2. Let's just pretend we got 2. What does the mean value theorem say? It says that there has to be a tangent line on this green curve that also equals 2. In other words, is parallel to that. Are there? Yeah, there would be one right around here, right? And there would be one right around here. So what did the mean value theorem say? The mean value theorem said, well, there has to be derivatives that equal that. So if I got a slope of 2, then there has to be a derivative that also equals 2. Remember that concept, guys? Okay. So now we're going to take that concept, we're going to extend it to integrals. Same exact concept. Okay. Same exact concept. We're going to apply it to integrals. And then we're going to look at how are we going to sort of take the mean value theorem, take this concept of derivatives, apply it to integrals, and then work fundamental theorem into it all. Okay, so it's all going to sort of come together, Cedric, right now. Okay. Here I have a weird way that I wrote this. Okay. Here's what it says. Here's an integral. If I asked you guys to describe that, what that's doing, and I did this at the beginning of the class, I did it purposely. If I asked you to describe what that's doing, how would you describe what that's doing? Just that portion of it. The integral a to b of f of x dx. Somebody tell me what that accomplishes. And I used a phrase. What was that phrase? Net change. This produces the net change. Be a little bit more specific. Net change of be a little bit more specific. You're right so far. Net change of f of x from a to b. Okay, now I'm going to ask you another question. When I say net change of f of x, what is that referring to? X's or y's? Well, f of x means what? Y values, right? So that represents the net change of the y values from a to b. Seem okay? Well, hang on a minute. What does that represent? Net change of the x values, because b minus a is the interval a to b being subtracted, right? So isn't that the net change of x values from a to b? So guys, if I have the net change of f of x being the change in y values, and this being the change in x values, doesn't that sound suspiciously like slope? So do you agree that if I divided both sides of this by b minus a, I would have change in y over change in x? So let's write that. Actually, you don't even need to. It's right here. So what did I do here? I divided both sides by b minus a. B minus a is a constant. Do you agree? It's the constant 1 over b minus a. So I can take that out and put it in front of an integral. And this becomes a super important formula. And it is the formula for the average value of a function. It doesn't sound like we did anything that impressive, does it? But we just did. We just did. We just calculated something really, really, really impressive. Guys, I'm going to put a, you know what, let's do this. Let's do this. Let's do these two examples backwards. Skip over 12, go to 13. We're going to do these two examples backwards. If I asked you guys to sketch this function, could you do it? What is it? Parabola that's been shifted up 1 unit. No doubt about it. Now I just put those dots on there, guys, because I don't really care about those. Specifically because this problem said I wanted to only look at the values between -1 and 2. Guys, what does this problem say? It says find the value of c guaranteed by the mean value theorem for integrals. Guys, here's my question. Ready? Vanessa, this is super important. Don't act like you're disinterested. Okay? This point right here is the point what? -1, comma 2. This is the point 0, comma 1. This is the point 1, comma 2. This is the point 2, comma 5. So I have 4 values that I know are on this, right? I have -1, 2. I have 0, 1. I have 1, 2, and I have 2, 5. Guys, what's the average value of f of x on the interval -1 to 2? What's the average value? Well, if I asked this to a 5th grade class or a 6th grade class, and I gave them those coordinate points, and they sort of have gotten into coordinates, and they've sort of gotten into average, I might have a good high achieving group, and they might say, average value of y, that, so I got to tell them f of x means y. Okay, so what's the average y value? They might take these y values and do what? Add them together, divide by 4. So they might say 2 and 1 is 3 and 2 is 5, 10 fourths. They might suggest the average value is 2.5. And would that be an okay way to think about it? It would be an okay way to think about it, right? Maybe another person comes in and says, well, average, okay, well, here I'm at 2, here I'm at 5. 2 plus 5 is 7. 7 divided by 2 is 3.5. That would be probably the least accurate way to do it, right? Take the beginning, take the ending, just find the slope. Not a great way to find an average, but would be a way to maybe come up with an idea. Reasonable? Do you see that there's issues with both of those, though? Because what about all the values in the middle, right? What about all the values in the middle? Let me give you a hypothetical, okay? Hypothetically, let's suppose that you are tasked with finding the average temperature in a day. You have to come up with the average temperature on your front porch. What are you going to do? What are you going to do? I'm going to give you $1,000. Okay, I'll put it down. There you go. I'm going to give you $1,000 if you can tell me the average temperature of your front porch over the course of a 12-hour period, within half a degree of accuracy. What might you do? I didn't ask you to do calculus, Michael. I asked you to give me the average temperature on your front porch within half a degree of the actual average. Awesome. And that's exactly what I was hoping somebody would say. They would take out a sheet of paper, right? They would write down all of the temperatures, maybe every hour, and then what? You could average them together, add them together and divide by 12. But what might somebody do that's better? They might take it every 15 minutes and divide by 48. But somebody who's even better would take it every minute. And do you see how we start to get into the calculus conversation rather quickly? That would be another way that you could do it. Yes, you're on track. Okay. So we see the problem at hand here, don't we? Okay. So, guys, the problem is I could add these together, divide by 4. That's fine. I could take the beginning and in the end, divide by 2. That's fine. What calculus allows us to do is find the average using integrals. And we said that the average value is equal to the integral from a to b of f of x dx over b minus a. Well, do we have everything here to accomplish that task? We have a function. Is it a continuous function? Doesn't have to be either, does it? Do we have a starting point and an ending point? Yeah. So we should be able to find it. So the average value is -1 to 2. All right, so I should have that. Average value. All right. So we have to take an integral. What is the integral of 1 plus x squared? Well, integral of 1 is x. The integral of x squared is something x cubed. What has to go in front? A third. And we have to evaluate that from 2 to -1 over 3. So what does that mean, evaluate it from 2 to -1? Plug in the 2, plug in the -1, and find the difference, right? So if I plug in the 2, minus, plug in the -1, over 3. Now I promise you guys I'm a math teacher and I'm right, okay? I promise you guys that when you do all of that math, you're going to get 6 over 2. No, you're not. You're going to get 6 over 3, which is an average of 2. Seem okay? All right. And we just found, guys, that's the perfect answer. That is the perfect average, right? It's not an estimate, it's exact. We are, guys, we're going to come right back to this, and we're going to come back to this. I want to go back to what Weeks did. So Weeks said that she was going to take out a piece of paper, right? And she was going to record that, okay? Now, Weeks, being the like super overachiever, says, I'm going to take temperatures every 5 minutes, okay? And she, let's be a little more realistic about this. Every 5 hours. So she's taking an average temperature over the course of multiple days, right? Okay. So unfortunately, she was doing this on her phone, and she put a whole bunch of data in, and some of it got lost. Okay. So she only has this portion of data. She knows that the 20th hour it was 42 degrees, and the 25th hour it was this, so on and so forth. There you go. There's your event. Oh, that happened. That was cool.
Oh, it's on the next one.
That was cool. Yeah, it was all going to come together. So she's got this data that she wrote down, right? Now, she knows that it's continuous data because, like, obviously the temperature is continuous, right? Like, she didn't write them all down, but were she to have, it would have been continuous, right? So I want to know the average temperature based on this data. So what could she do? Well, the super trivial person, when I ask you for the average temperature over those 5 hours, or over those, not 5, but over those 30-hour period, right, would do what? Take this, 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 add them together, divide by 1, 2, 3, 4, 5, 6, 7. That would be called what's known as an arithmetic mean. And so she does that, and she gets 100. No, she doesn't. And she gets an average of 40.428. Now, Weeks felt pretty good about this because she did this accurately every 5 hours on the hour. So there's a consistent gap in the x's. So this seems like a reasonable way to do it. Agreed? Yeah. But what does the student who's been sitting in a calculus class say? They say, I really want to do this using integrals. And this is where Michael was going. But the problem is I don't have a function to integrate. Do I? So Weeks accurately says rectangle time. Because she did. That's exactly right. That's where we're going. So she says, okay, well, I don't have a function, but I know this much. What was the lowest temperature? So I can go up to 60, right? So 10, 20, 30, 40, 50, 60. This is going to be, so we have a break. So we're going to start 20, 25, 30, 35, 40, 45, 50, 55. Was that it? 20, 25, 30, 35, 40, 45, 50, 55. What? Oh, I only got to go up to 50. Okay.
On the y-axis.
Oh, all right, I got it. 30. Thank you. All right, so Weeks very accurately said, let's go to rectangles. And this has got to go out of the way. So at 20, I'm at 42. Read these numbers to me quickly. Go. 42. All right. So she sees this. And so she says, okay, rectangle time. I say trapezoidal time because of those methods, we definitely figured out, go away. We definitely figured out that trapezoids work better, right? And guys, because I don't have a function, we're only left with rectangles or trapezoids, aren't we? We don't have any other options. So I'm not going to do rectangles because we found those to be inaccurate. I'm going to do trapezoids. So right away, guys, the question is, well, why do we have to do the trapezoids? Why do we have to do the rectangles? Well, here we see it. We have no other option, right? We have no other option. It's discrete data, right? In other words, there's things missing, right? Things missing. So how do I find the area of trapezoids? I take the average of these two numbers and then multiply by 5. So it's going to be this plus this divided by 2 times 5, right? And then it's going to be this plus this divided by 2 times 5, right? And I'm going to do that all the way through. So it's going to be, so the trapezoidal is going to be the following. Ready? I'm going to integrate from 20 to 50 my function over 50 minus 20. That's going to give me an average, right? Now, Christina's sitting there saying, Picardo, you're not going to integrate. You don't have a function. You can't integrate. And I'm going to say, well, I don't have any other option. This is the only way I can integrate. So, well, what's it going to be? Do you agree that for the trapezoids, everything's going to get multiplied by 5? So is it fair that I just take these two numbers, add them together and divide by 2 and then multiply by 5? What's the average of 42 and 38? 40, right? So do you guys agree that the first trapezoid is going to be 38 plus 42 divided by 2 times 5? So isn't that what this is going to do? So what's the average of these two numbers? 34.5. And then the average of 31 and 29. And then the average of 29 and 35. And the average of 35 and 48. And the average of 48 and 60. This is 41.5, not 43.5. And the average of 48 and 60 is 54. Gives me 1,160 over 30, which is approximately 38.666. So the arithmetic mean was clearly inaccurate. In fact, it's almost 2 degrees inaccurate. Rather significant, right? Rather significant. Based on the discrete data, right? Based on the discrete data. Guys, do we agree that most data is discrete? Right? Even though, like temperature is continuous, but the way that we collect that data is discrete, right? Yeah. All right. Guys, how can I take discrete data and turn it into something that's functional? Well, if Weeks had done her job and not taken the temperature every 5 hours, but took it every hour or maybe every minute or maybe every 30 seconds and puts that into a calculator, can't you do a regression? And didn't we do some work with regressions in Algebra 2, right? Now, one of the regressions, guys, ready? Look at me. What happens typically when we take temperatures? During the day, temperature goes up, and then it goes down, and then it goes back up, and then it goes back down, and then it goes back. So what would you consider temperature to most closely resemble functionally? Sine curve, yeah. So if I go back up here for a minute to example 12, right? Here, Weeks found herself in New Braunfels analyzing temperature from 9 a.m. to 9 p.m., right? And so she took all of her data and she calculated the temperature every minute for that from that 9 a.m. to 9 p.m. period of time. How many hours, by the way, is that? 12 hours. So for 12 hours, every minute, she took a temperature. Then she put all those temperatures into her calculator. And then she did a sinusoidal regression. And the calculator spit this out as the regression model. Now, what's nice about that regression model? Well, it gives me a pretty good idea of what the actual temperatures were during the course of the day, right? What if I asked you guys to give me the average temperature during the day? So now what is Weeks going to do? Is she going to take so she did every minute for 12 hours, 60 times 12, 720. She has 720 pieces of data. Is she going to find the area of 720 trapezoidal things, add them together and divide it by 720? No. She's going to do it using calculus now, right? Because she has a rather good model. Now, is it precise in terms of being perfect? No. But is it a pretty good model? Sure, right? So what are we going to do? Well, we want to know the average value. And we said that the average value is equal to, now guys, by the way, you all understand that calculus doesn't understand time, right? So time started at 0 and ended at 12. Check it out. Now, fortunately for us, this is a calculator question, right? So I'm going to take this and we're going to plug it right in. So I am going to do a integral from 0 to 12 of 50 plus, is it plus? Sine of 14 sine of pi t over 12 dt over 12 gives me oh yeah, this one right here. Yeah, because remember to find the average value, I got to do the change in y over the change in x, right? Oh, yeah. So you're saying I could just, yeah, I could put it in front of you. Either way. Yep, either way. No doubt. 58.9127. Hey, guys, guess what we just did? You know how, like, the National Weather Service, right, gives you the average temperature of the day, and they record these things, right? Well, what do you think the National Weather Service does? Well, they have that little thing sitting at the Greater Rochester Airport that records temperatures, right? Well, what happens? Every few seconds, that thing sends the temperature to some database, right? Well, what does that database do? It takes all of those temperatures, fits it to a sinusoidal regression model, right? And then does this and gives you the average temperature for the day. It doesn't take all those numbers and divide. It doesn't do that, right? This is exactly how it's found. Pretty cool, right? Good. Thank you, Jillian. We are going to come back to 14. I don't want to come back there yet. So here are some things that we can do with this, guys, right? So far we have this idea that I can find an average value over the span of time. Pretty powerful stuff, right? Over the span of a domain. Doesn't have to be time, it could be anything, okay? So here are some different things that we can do. Here's one of them. And this is really, can you play with the concept? I said, I want to find a number such that the average value of the function on the interval is equal to 3. I want the average value to equal 3. I gave you a lot of data there, didn't I? But it's all in reference to an average value. Well, the formula for average value is this integral from a to b of f of x dx over b minus a. So what do I know here, guys? Do I know what the average value is? Yeah, it says it right there. It's what? 3. What's the beginning of the interval? It's the ending. Of the function over b minus 0. Now, if we look at that, it seems complex. It seems difficult. Watch how easy a problem like this actually is. I want to solve this. It's an equation, right? So isn't this 3 over 1? Well, if I do that, don't I have a fraction equal a fraction, which means I can take a cross product. So isn't it fair to say this integral is equal to 3b? All right, so the integral there should be a dx on here, sorry, is equal to 3b. Okay, let's integrate it. What's the integral of 2? 2x. What's the integral of 6x? 3x squared. Integral of negative 3x squared is negative x cubed. We're integrating that from b to 0 equals 3b, right? Now, this was our first fundamental theorem of calculus, right? The first fundamental theorem of calculus said if you integrate something from a variable to a constant, then I can simply do what? Take the b in, simply plug it in for the x, right? So isn't it the same as this? And from this point forward, we're done with calculus. Now I just got to solve that equation, right? I'm going to move all my b's to the right-hand side because I want my b cubed to be positive, okay? So b cubed minus 3b squared plus b equals 0. Give me something I can do to solve that. Take out a b. And if I take out a b, I get that. So one of my solutions to this is 0. And then, guys, is this factorable? No. So if it's not factorable, can I use the quadratic formula? Okay, so if I use the quadratic formula, it's negative b. What's the negative? Yeah. So it's I know there's b's in the problem. I'm going to confuse everybody now. But quadratic formula is negative b. Yeah, you get it. Yeah. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So the negative b is 3. Plus or minus the square root of, what's negative 3 squared? 9 minus 4 times 1 times 1. 9 minus 4 is 5 all over 2 times 1 all over 2. Now look at the interval, guys. I want the solutions from 0 to b, right? So I don't want any values that are less than 0, do I? Let's just make sure. What's 3 plus radical 5 over 2 is positive. Radical 5 is a number between what? 2 and 3. 3 minus a number between 2 and 3 is positive, right? So all numbers are acceptable here. We're in good shape. Cool? All right, so that's a way that I could sort of throw a problem like this at you, okay? Guys, these problems below, we're going to just do one of these and then we'll be done. Question number 17, it's basically, it's saying, okay, here's an integral. I want to know when this integral equals 0, right? Guys, again, to me, it's not just about being able to solve the problem, it's about being able to interpret what's being asked. Here's what's being asked. If I asked you guys to sketch this. If I said, guys, I need you to sketch this, what would you do to sketch it? Give me something you might do to sketch it. I'm going back to like pre-calc. This is not a calculus question. I just want to know how to sketch that graph. Give me some things I can do. Plug numbers in. Sure, I could do that. That's one thing I could do. Give me something else I could do. What are nice things to know about a graph? Find the roots. So that means I would set this equal to 0, right? So if I took out a t, I'd have that, right? Guys, do you agree that this is a difference of squares? Now notice what I said. I didn't say a difference of perfect squares. I just said a difference of squares. Well, as a difference of squares, I can still do a t plus and a t minus. If this was 9, what would go in the blanks? If this was 25, what would go in the blanks? Well, if it's 7, what goes in the blanks? Radical 7. So that means I have 3 roots. I have roots of 0 and positive or negative radical 7. So sketching this would give you a picture that looks kind of like this. One more thing, guys. What was the degree of the polynomial we're trying to sketch? 3. So what does that mean about the end behavior? They're opposites. Yeah, so it's a positive end behavior. It's going to look like one of these. Right? So maybe it looks like one of those. All right, so Sarkis, this is where I got to know if you understand what the heck the problem's really asking. The problem is saying, if I start at -5, what value do I need to go to on this function so that I accumulate 0? So if I start at -5 and I start to accumulate, starting at -5, going to that first root accumulates what? A lot of negatives, right? But then I got this little piece here and this little piece here. What do you guys think happens with those two things? They probably cancel each other out, right? And then I start to accumulate some what? Some positives. So is it fair to say that an accumulation starting at -5 is going to have to go to some value greater than radical 7 to accumulate 0? Because these two things are going to cancel each other out, right? Guys, get what I'm doing here? Kind of cool, right? One more thing. Hang on a minute. I want to make sure I phrase this right. Actually, quite honestly, I just forgot what I was going to say. It was going to be important too, Cheyenne. It was like, darn it. One more thing. Oh, one more thing. If I wanted an accumulation of 0, what's the very simplest way to do it? Guaranteed to work every time. Don't go anywhere. So what value of x will accumulate 0? -5, right? No doubt about it, surely -5 to -5 accumulates nothing. So one of the answers is definitely going to be that. That's going to be real important tomorrow. All right, so one solution is x equals -5. All right, so I know that's true. Okay, now let's do the calculus. Okay, does the idea make sense? All right, so we know if we don't move at all, I accumulate nothing. I know I got to accumulate at least past radical 7 because I got to get some more positives, right? Okay, so let's do it. So let's take our integral. So we are going to integrate this. So we're going to actually do the math, right? So it's going to be 1/4 of t to the 4th minus something t squared. What am I going to put in front of this to get a 7? 7/2, absolutely. And I'm going to evaluate this from x to -5, right? What do I want this to equal? I want it to equal 0, right? So if I plug it, go ahead. Well, exactly, but I'm not dividing here because I don't care. Again, this is where we're going to start to like interlap some of these theorems now a little bit, okay? I'm not asking for a mean, am I? Am I asking for an average here? No. I just want to know if I start accumulating here, where do I have to stop so I've accumulated nothing, right? So this is not a mean value theorem problem. This is a fundamental theorem problem. Cool? Okay, so we're interweaving all these things together a little bit here. So solution, x equals -5. I got that. I'm going to go ahead and I'm going to plug in my x. I'm going to plug in my -5, take my difference. All right, going to get that. That's going to give me 1/4 of x to the 4th minus 7/2 x squared minus, I think it's actually going to be from plus. Guys, I'm a math teacher. Believe me, I promise you, you're going to get minus 275 fourths. equals 0. Now, Cedric looks at this and he says, Picardo, you're a good dude and everything, but I'm not doing problems with 2s and 4s in the denominator. So Christina raises her hand and says, that I messed up? Oh, yes, go ahead. I did. Right? I did, right? I plugged in the x, right, and got this. I plugged in the constant and got this. Now here's the difference. The oh, I see what you're saying. Oh, hold that thought. I see where you're going with it. Hold the thought. Cedric, what can I do to get rid of these things in the bottom? Multiply everything by 4. Not 12, but all right, so I get that. And so we look at this thing and we're like, you know, Cedric's like, Picardo, you're a good dude and everything, but I don't know how to factor this. And I say, well, there's 3 terms, and you know, to get to x to the 4th, I know I need one of these and one of these. Right? Now watch this. You guys want to see how smart you are? Guys, I know one of the solutions is this, right? Well, if one of the solutions is this, what does one of the factors have to be? X plus 5, right? Well, there is no x plus 5. There's an x squared. Give me something that would give me an x plus 5 if I had an x squared. X squared minus 25, right? Now, it just so happens that if I make this plus 11, negative 25 and 11 is negative 275. Negative 25x squared and positive 11x squared is negative 14x squared, and that gives me x to the 4th. So, I get solutions of positive and negative 5. Now, why do I not care about this? Because the root of this is what? Yeah, well, not negative, but imaginary. Yeah. X squared plus 11 is negative, is never going to equal 0, right? Cool. Now, what does that mean, guys? That means that if I go negative 5 to 5, right, I've accumulated nothing. That means that this function must be perfectly symmetrical, right? It must be perfectly symmetrical to accumulate, perfectly symmetrical and odd, right? It's an odd function. Isn't that cool? Yeah, so